So this is integrals with logarithms, and we're not actually using logarithms, but the result of the integral is a logarithm. So if you remember, if we have y equals ln of x, we get y prime is 1 over x. And this is what works that way as well with an absolute value. See, 1 over x is defined with negative numbers, but the natural log is not. You can't have negative inputs. So the absolute value allows us to keep this defined over the whole thing. It also works both ways. If you think about it this way, if you have y equals ln of x, you would get y prime equals 1 over x. Now, if you put a negative in there, you would still get the same thing. This is 1 over negative x, but with chain rule, you throw the negative 1, you still get 1 over x. So the whole idea is our integral here is the absolute value of x inside the natural log. Now, if you have a number in front, remember that 2 is just going to come out. So it would look like this. So you just end up with 2 ln absolute value of x. But you need to make sure that you include the absolute values. So you just put the 2 in front. Now, I want to review exponentials as well, since we'll have some of these problems appearing. So if you remember that t, again, is going to affect this problem. And we want a nice quick way through here with these very, very basic ones. So we're going to do it with u first to remember how to do this. So we understand. We already know how to do it. We want to know why. So you end up with this. So now we do our little u substitution. And we end up with 1 over t e to the u du. So it just becomes 1 over t e to the u, which is e to the tx plus c. So on each of these, we also need to make sure that we put plus c after all of them, because there are constants. All right, but if you notice that t just becomes 1 over t, just like before with our other stuff. So whatever your exponent is, you can just put it in front. And if there's a number in front, the same idea. This is just 2e to the x, not e to the e to the x plus c. And so if you have a 7, this would be 7 e to the 5x. And then if you notice, the same idea, if there's a t here, you put it in front as a 1 over t. So if there's a 5, you just put it down here like that, plus c. So that's how you can do them very, very quickly. If you have just plain old 5x, there's no x squared or anything up there. There's no reason to use u substitution. Just put it down as a denominator. Now, how this is going to happen with a lot of these logarithms is they're going to be part of the problem. So we want to simplify just like we did before. So we're going to divide every single one by themselves. So x squared over x squared plus 2x over x squared plus 1 over x squared. That's supposed to be an x dx. And then we simplify. So we get 1 plus 2 over x. See, there's our natural log. Plus, and then we want to rewrite that last one with a negative exponent. And so this is now where the logarithm will also occur. So we take our integral, this would be x plus, and remember if there's a number in front top like this right here just becomes 2 ln of x, absolute value of x, plus 1 over x squared. Oops, we didn't take its integral. So we're going to add 1. So that's negative 1. X to the negative 1 plus c. And so we rewrite this x plus 2 ln of x, the absolute value, minus 1 over x plus c. Now remember, you can check by just taking the derivative on all of these. So this one would be 1 over x. This would be 2 over x, checks, right? This is e to the tx times t. So the t's cancel, giving us this. This is 2e to the, it's done. And then the 5, so this is 7/5 e to the 5x times 5. The 5 cancels, taking us back. So it works the same way here. Derivative of x is 1. This would be 2 over x. This would become this. So negative 1 when you subtract 1, making it negative 2, right? And you bring the negative 1 down. So there we go. So negative 1, subtracting 1, checks perfectly. All right, with u substitution, same thing. We're going to go u equals 8 minus 5t. So du equals negative 5 dt. dt equals du over negative 5. And then we resubstitute. So this becomes, I'm going to put the negative 1/5 outside. And then this would now become 1 over u du. And then that's just natural log of u. So 1/5 natural log of u plus c. And then this is negative 1/5 natural log, oops, gotta have it, 8 minus 5t plus c. There you have it. All right, let's try another one. So if you notice here, we have u equals, ln of t would be the best choice because it is the most inside. So you can also use it within the u substitution. So this is now t du equals dt. So cosine u over t, it's not a t, t du, the t's cancel, and there you go. So now the integral of cosine is sine, and sometimes we get confused with the negatives. Remember, with integrals, if you end with a cosine, then we got to have a negative on there because the derivative would make it negative. All right. So this is sine. Derivative of sine is cosine plus c, and then we plug in our natural log plus c. And there you go. Now, no absolute value here because the t was not starting with it, so we don't end with it as well, and it's also not part of that integral. All right, let's try one more. So if you look at this one, it's really a little bit difficult to see, but you always want to start with the bottoms. It's the best place to start. So du equals e to the x dx, and so dx equals du over e to the x. So now let's substitute. See, it cancels perfectly. 1 over u du, so that would now become natural log e to the x. Oops, sorry, I went way too quick for you. U plus c. And then now when we plug it in, we get to do a nice little trick. So if you notice on each of these, can the x be negative? Yes. So we have to leave the absolute value to keep it positive. Because remember, if you put negatives in here, this is going to become an error. So same thing here. Can this be negative? Yes. Can this be negative? It's not even part of that problem, so there's no absolute values. We don't have to worry about it. Now, this one. Can e to the x plus 1 be negative? No, e to the x is always greater than 0. So e to the x is greater than 0. It's always positive, right? So if we have always positive plus always positive, right, then we know that e to the x plus 1 is also greater than 0. In fact, this is going to be greater than 1 because we're adding 1 to both sides. So we can now take that absolute value and change it to a parenthesis instead. So you don't need absolute values if your results from the inside will always be positive no matter what x input you give. So it's a nice little trick. So if you have things like this, natural log of x squared, then you can just write natural log of x squared. But if you have natural log of x cubed, well, that can be negative, so you've got to leave it. So always verify the inside. If it's always positive, throw the parentheses away. And there you have it.